Delete in array. Deletion in an array refers to removal of a value at a specific position in the array. We know array is having fixed positions, that is, each position will be having an index and each position has its own significance. Indices will be from 0, then 1, 2, 3 and so on. Here, first element will always be kept at 0th index and the remaining elements will be kept at consecutive indices. Because of this, whenever you want to delete an element, depending on the position of deletion, you may or may not have to rearrange other elements. The main thing that you want to learn in deletion is when do you want to rearrange other elements and what is the rearrangement to be done. Let us understand this by taking case by case. In each case, we'll understand what is the rearrangement to be done. Let us put some numbers here: 12, 7, 21, 40, 33. Let these be the numbers in our array. The first case of deletion is deletion at the end. This is the simplest case of deletion. If you want to delete from the end, one more thing, when I say end, I mean whatever be the position till which you have filled the array, that last position is called as end. It is not the actual end of your static array. That is, when you initialize the array, you would say, I want the array to be of some particular size. Here it is 6. 6 is the size of this array. But I have only filled this array till 4th index, that is position 5. Which means when I say end, I mean 4th index or the 5th position. It is not the actual end of array. Whatever be the position till which array is filled, that is called as end. If I want to remove the element that is placed at the end, what should I do? This is the simplest case of deletion. I can simply remove this element off. It will not affect any other elements and there is no need of any rearrangement. One more thing, when I say erase it off, I simply showed by erasing that element. What are you actually going to do? Are you actually going inside an array and erasing something? No. What are you actually going to do? In reality, you are going to decrease the length of the array. This memory is already allocated. You are not going to deallocate the memory for one particular element. What are you going to do? You will have a length variable. You will be keeping track of the length of the array. This length initially would be 5. Let us say if you have this element, it will have a length of 5. If you simply decrease this length and say that my array is now of length 4, what does it mean? It is as good as removing the last element, because when you say length is 4, you are only counting till this point in the array 0, 1, 2, 3. You are not counting the element 33. This is as good as removing that element. So this is how you actually do removal. Next question is, what is the time complexity? I already told you that whenever you are learning any algorithm, make sure that you are able to identify what is the time complexity of this algorithm and what is the space complexity of this algorithm. If you are not able to do this, that means you have not understood the algorithm. If you understood the procedure, you should be able to say what is the time complexity, what is the space complexity. In this case, you are simply removing the element at this place. It is a constant time operation. So, order of 1 is the time complexity. What about the space complexity? Space complexity, here you have an array which is already allocated. While you are deleting, you are not using any additional space. Because of that, space complexity is also order of 1. So it is a constant time and constant space operation. This is it about deletion at the end. Next case of deletion is, second one is deletion at the beginning of your array. How can you delete the element at the beginning of your array? If I remove this 12, what will happen? There will be an empty space at the beginning. But this should not happen. I told you, generally in an array, you will have elements filled from the first position, that is 0th index, and then in consecutive positions. You won't have empty spaces in between. Because of this, if you want to delete the element that is at the beginning, you have to fill the space. Can I simply fill the space by putting 40 here? Is that an option? No, it is not an option because in an array, position has its significance. So whenever you have some elements in the array, you should always maintain order of elements. If you want to make any changes, always make sure that the order of elements is maintained. If I have to maintain this order, the only option is move all the elements one step towards left. If I do this, automatically 12 will be gone, because what will I do? I'll take 7 from here. I'll place 7 in this position. 21 will be taken from here and placed in this position. 40 will be taken from 3 and placed at 2. This is how I'll delete the first element. Now you can see automatically the beginning element, which was 12, is now deleted. This is how deletion at the beginning is done. What is the time complexity of this operation? What did we do? If there are n elements in total in your array, you are moving all the n elements one step towards left, which means time complexity is order of n, because you have to move all the elements. Next is, what is the space complexity? Coming to space complexity, you are not using any additional space for this deletion. This array is already existing. So space complexity is order of 1. Time complexity order of n, and space complexity is order of 1. Next case is deletion at a specific position. What is this specific position? We already discussed what if it is at the end and what if it is at the beginning. Next thing is, if I have to delete at any position, any specific position, what is the procedure? Let us put two more numbers here, 25, 27. If I want to delete at any position, let us say I want to delete from position 2. Can I simply remove this off? No, it will keep an empty space, and we should not have such empty spaces in the array. It should be in consecutive positions. I also told you, you have to maintain the order. What can you do then? You have to move all the elements which are occurring after this element one step towards left. You don't have to touch any elements which are to the left of this. Whichever are the elements present to the right of this, for each of those elements, you have to take them and move one step towards left. This is how you do deletion at any specific position. How will you delete 40, which is present at position 2? You will take 25 from here. You will move it to this position. You will take 27 from here. You will move it to this position. This is how deletion is done. What is the time complexity? Coming to time complexity analysis, I've told you that whenever you want to do time complexity analysis, always think of the worst case scenario. Do not think like, if deletion is at the end, I can simply remove it off and time complexity will be order of 1. Do not think like this. Instead, you have to think, what is the worst case? In worst case, what can happen? This specific position can be the beginning, the first position. In this case, I have to move all the n elements one step towards right, which means time complexity will be order of n. What about the space complexity? You are not using any extra space. Space complexity will be order of 1. Order of 1 means constant space. So what did we learn till this point? 3 cases of deletion. One is at the end, next is at the beginning, and third is at specific position. If it is at the end, time complexity is order of 1. Space complexity is also order of 1. What did we learn about beginning? Time complexity will be order of n, and space complexity will be order of 1. What if it is at a specific position? Here also time complexity is order of n and space complexity is order of 1. Next thing is, let us see how to write a pseudocode for this. I showed you in this pictures how to delete, but actually if you want to implement this, if you want to write a code, how are you going to write that code? This is what I want to show you, because as a computer science student, you should know both these things. You should be clear on the theoretical side, and whenever you want to implement, you should be able to directly implement. The main point is, Once you are clear about the procedure, implementation should never be a bottleneck for you. You should always know how to implement the idea that you have. Let us say you want to delete. In order to delete an element, what should you have as arguments? One is the array, then you should know what is the length of array, and the third thing is position. Which position is the one from which you want to delete? These are the things you have to know. Let us see what is the procedure. First thing, the first step is always to confirm that the position that you're deleting from, that is a legitimate position. For example, here if I'm telling you delete from position 4, it is not a valid request because at position 4 there is nothing to be deleted. The length of this is only till 3. So such positions are invalid. Similarly, if I tell you delete from position -1, this also can't be done. The first thing is you have to confirm that the position is a legitimate position. If what should you check? If position is lesser than 0 or if position is greater than or equal to length. In both these cases, you will say it is invalid position. Let us say you will return -1. -1 is showing that position is invalid. Next thing is, after this point, you know whatever position is provided, that is a valid position, which means you can delete from that position. Then what is the procedure? If you know you can delete, you should move all the elements which are present after that position one step towards left. This is what we learned. This is the procedure for deletion. Where should you start this from? You should start this from the exact position, and then every single element that is to the right of it should be moved one step towards left. This is the procedure. For, we'll write a for loop for this. Where should you start from? From position to, till which point should you do? Length -2. Why is this length -2? Because if length is the actual length of your array, that is here if length is 4, then the element will be present till index 3. So till index length -1, elements will be present. What are you doing? You are standing at the position before that and you are going to say I'll move next element to this position. This is what you are going to do. So you should be standing at length -2 and then you should be pulling length -1 element towards this position. This is what we are going to do. So from position till length -2, what are you going to do? You are going to do a of I is equal to a of I plus 1. That is, you are going to take the next element and pull it to this position. After this loop, what will happen? It will be as good as the element is deleted. That is, when all the other elements are moved one step towards left, automatically this element will be removed from the position. Next thing is, length is now changed. Total length of the array was previously 4. If I delete one element, it will become 3. So whatever be the length, that should be decreased by 1. That is the next step. I'll do length is equal to length -1. That is, I'm decreasing the length of the array and then I can return array. This is the procedure for deletion. Let us just go through this once more. Deletion, I'm having 3 arguments. One is the array itself, then I have the length of array and the position from which I want to do deletion. After that, what is the first thing? I have to verify that whatever position is provided is a legitimate position. It is not an invalid one. How will I check that? It should not be less than 0. It should not be greater than or equal to length. In both the cases, I'll return here itself. Otherwise, if the position is a legitimate one, then I'll go to the for loop. I'm going to move all the elements starting from the position till the end. I'll move all of them one step towards left. How will I move one step towards left? I'll do a of I is equal to a of I plus 1. Whatever is present in I plus 1, that will be copied to I. After this, my deletion is completed. Then I'll decrease the length of array by 1 because one element is deleted, length should be decreased. At this point, procedure is completed. You can return your array. This is the total algorithm. What is the time complexity here? Time complexity is order of n. Why is this order of n? Because this for loop In worst case, it can run for n elements. That is why time is order of n. That is, in worst case, you can say this position is position 0. So this will be 0 to length minus 2. That is almost n elements. Order of n is the time complexity. What about the space complexity? For deletion, you are not going to occupy any additional space. So space complexity is order of 1. One more thing, whatever different cases of deletion we had learned, deletion at end, beginning or specific position, all of these are included in this algorithm. In this algorithm, if you give position as 0, that will be beginning. If you give position as length minus 1, that will be end. If you give any specific position, it will work for it. Why did we learn in different cases? Because I wanted you to understand what happens in each case. Thereafter, you can unify everything and write an algorithm. So this will make concept clear for you. Keep this in mind. Time complexity of deletion is order of n. Space complexity is order of 1.